So the average rate of change is simply the slope. All right, so the first thing I do is find f of x1 and f of x2. What is sine of negative pi over 2? Negative 1. Because when you have a negative angle, you go clockwise. So it's negative 1. And sine of 0? 0. So what we have here is 1 minus 0 over 0 minus pi over minus negative pi over 2. What does that become? 2 over pi. Because it's the top fraction times the flip of the bottom, which makes it 2 over pi. I'll go ahead and do the second one with these points. What do you notice about negative pi over 2 and 3 pi over 2? Where are they located in the unit circle? Same point. Since they're the same point, what's going to happen to the function? It becomes 0. Because the numerator, these are the same points, so it's going to be negative 1 minus negative 1. That's going to be 0 over 2 pi, which is 0. Are you okay with that? Let's get the next one. We have all these to do here. Oh, then. Okay. Bless you. Question A. Which of the following is the bicyclist's average speed in miles per hour over the time interval 0-1? So your first point, your x1, y1 is 0, 0. Your x2, y2 is 116. What's your answer? D. Because it's simply 16 minus 0 over 1 minus 0, which is 16. So that was an easy one. Which of the following is a bicyclist's average speed in miles per hour over the time interval 1 and 2.5? So what do you do? Mm-hmm.
Yes.
You have it?
Yeah.
What'd you get?
Is it 4 miles deep?
Anybody agree with that? How'd you get it?
So I took the y value and subtracted. Well, it was the fx2 minus fx1.
Right, which is
the y value. Then I subtracted the 2.5 minus 1 for the x value on the bottom. And after that, I divide y divided by x, and it gave me 4. Since the top was 6 and the bottom was 1.5, and that's when I divided.
Very good. That's exactly right. That was pretty quick, too. So everybody hear that? So take the y value, which is 22, minus 16, over 2.5 minus 1, which is this. There's your x1, x2, y1, y2. Just do the slope. Now we're going from 2.5 to 3.5. Well, when would it ever be negative?
No.
Sure. Because isn't the average rate the slope? Can the slope ever be negative? If it was going down, if it was a decreasing function, yes. Or in this example, between 2 and 3, what's the average rate of change? 0. There is no change. So yeah, so be very careful. So it doesn't always have to be positive. So this answer is what? The 6. It's 28 minus 22, 3.5 minus 2.5. Okay, now it gets fun. How do you find the instantaneous rate of change, or instantaneous speed? But what we're looking for here is at time equals 1/2. How do you find that instantaneous rate of change? But that's going to give you the slope of the secant line. And that slope. How do we do instantaneous rates of change? We will use the 1 and 0 points, yes. But we also have to incorporate the 0.5. First. That's 22, that's 28. So our graph find the instantaneous rate of change. We have to find 2 rates of change. One from 0 to 1/2, and then one from 1/2 to 1. Then we use those values and find the rate of change.
Nice.
Get it?
And then we subtract all.
Now I think we're taking the average.
Oh, right. So basically we divide those two, right?
Right.
Oh, okay, thank you.
See what else we're going to do. Let me put ahead of this.
I got two value answers for, from 0 to 0.5 and the other one from 0.5 to there. So do we just divide values? Value, but I don't know what to do next.
What do you do with those, ladies and gentlemen? You're right, you will have two values because we're looking at the first half and the second half. What do you do with those values? We're looking for the instantaneous speed, the velocity at that point. Any ideas? Okay, if you did that, what do you get? Yeah.
Oh, okay. Oh, okay. Then the answer is D.
D.
Yeah.
Right, because we're looking for, since we're looking at the two endpoints, or two domains, then we add them up, divide by 2. It's looking for the instantaneous, the average. What is the instantaneous speed when t equals 2? Remember, look at that. The reason they picked 2, because if you look at right here, it's increasing. It's increasing.
2 and 3 is constant.
And then between here, it's constant. So, like from here to here, what is it? What's this? Because we know this side's 0, so we don't have to worry about that. So what is this one going to be? From 1.5 to 2, it's 20 to 22. Work it out. Don't guess.
Oh, right.
Your answers are questions. So what you're looking for is half of 2 is what? Here's it. It's starting at 20, going to 22, and it's 0.5. So it's 1. At 3, this one's a trick question. At 3, is it raising before or after 3? Or at 3?
At 3.
Sure, look at it. There's the increase. It's afterwards. So the instantaneous speed is what at that point? 0. Because it's the same speed on both sides. Which of the following choices gives maximum speed in miles per hour and the time at which it occurs? Which of the following choices gives the maximum speed? The speed of bicyclist is 50 miles per hour and it occurs at 3.5. Speed is 50 miles an hour, it occurs at t.1 hours. What is that question asking us? What's that? Yes. Which all three of these conditions. Where would you find it? Get smaller. So, now we have all four of the conditions. And you pretty much can't just guess at it. You got to do the math. Are you working on it?
Yeah.
Okay.
Yeah, I don't have it. I forgot.
Too expensive. You have to do a bunch of calculations. I'm not going to lie to you about that. You have to take small intervals. But you can also pretty much tell by looking at it. 50 miles an hour at 3.5. Well, that's 25 miles, or 36 in 4 hours. So what we're looking for is the instantaneous rate of change at any one point. We're looking for a speed of increase. And so that's what you have to look for, is at what point does the greatest increase happen? It happens right here. Because of the steepness.
I never thought of that. And I was overthinking it. Never mind. You know what?
But I'm just saying the way it looks. But then mathematically, you still have to do it, prove the actual values. And I still have 26 more questions. That's why I was wanting to hurry up with this stuff. So the answer is D.
I knew it.
We zoom in. There. You're asked to find the limits or tell me why they don't exist. So write these down first. We have 4 of them. Limit of g of x as x approaches -6, x approaches -3, x approaches 0, and x approaches -1.9. Okay. At -6, does the limit exist?
Yes.
What is it?
0.
Right. At -3. -4. At 0. Right. Because if you're coming from the left, you go to -4. If you come from the right, you go to -2. If you just plug in the value, you got -3. So they have to approach the same value, and the limit has to exist. So at 0 it doesn't exist. At 1.9. -1.9. Yeah, so it's right there. Yeah, so since both directions it approaches the same value, it's a horizontal line, so it's -4. That one exists. It's -4. Explain why the limit does not exist. Only 2 of them. Yes, why?
Because you can't divide 0. Or wait, I think you can.
Well, Mary, it doesn't have to exist at 0. It just has to approach the same value. So why does it not exist? It doesn't have to exist. The point doesn't have to be at 0. What's the graph look like of this function? We know we can't use 0. So what happens if x is negative? What happens if x is positive? What can we determine? Let's see. If x is positive 1, what's y? Positive 1 over 1 is 1. And x is 2. What do we get? 2 over 2 is 1. When x is 3, 1. And we can't use 0, so we have that. What happens if it's negative 1? Negative 1. Because the top is negative, the bottom is positive, so it's negative 1. When x is negative 2, negative 1 again. So as we approach 0, the limit doesn't exist because from the left it's a negative 1, from the right it's positive 1. That's why the limit doesn't exist. Yeah, if you don't see the graph automatically, just plug in some numbers. You know it's centered around 0, so pick some numbers on both sides and see what the graph looks like. That's right.
Oh,
Find the limit as x approaches negative 1. Negative 11. Remember, when we deal with limits, the first thing you all want to do is, if it works, plug it in there. So the limit does exist, and it's negative 11. Was that negative 1? 12 times negative 1 is negative 12 plus 1. Are there any asymptotic points here, or points that make the function undefined? No. Is the function continuous? So therefore there's no asymptotic points in there, so no x's that creates an undefined function. So therefore we know the limit has to exist, since it's a continuous function. Plug in negative 2 in there. What do you get? The whole thing. Plug in your limit value. Negative 19 is correct. Good. So your first thing you should do is determine one of three things. If it's a fraction, and you plug it in there, does it give you 0 over 0? If it gives you 0 over 0, then we know we have a removable discontinuity. If it's a fraction and it doesn't equal 0 over 0, then we got to try something else. There'll be some problems with that in a second. Third is if it's just a function, plug it in there. If there aren't any undefined locations, then the limit exists at that point. You don't need any calculators here. Well, let me work it out. Anyone want to work it out? Or is everybody okay with negative 1? I'll work it out. This is question number 7. Squared Plug it in there. -1 cubed is -1. -1 squared, +1. Positive times negative is negative. 2 times 1 is 2. Positive negative is negative. 5 times 1 is 5. Positive times negative is negative. 2 times 1 is 2. Those equal -9. That's your limit. The first act of students when you come to these kind of problems is stare at it. What happens if you put 0 in there? 0 over 0, because you do the calculate. So 0 over 0. What does that tell us? We can factor something out. Or we could, there is a removable discontinuity. We could do something to it. But we can't factor anything, really. So how do we approach this one? The conjugate. We multiply by 1. 16h plus 1 plus 1 over radical 16h plus 1 plus 1. Very good, yes. Whenever you have a radical in there and it's 0 over 0, the first thing you want to try then is the conjugate. That's a FOIL. The radical 16 plus h plus 1 times this radical 16 h plus 1 equals what? Yeah, you get rid of the radical. Because it's squared. I'll do it the long way. There's 1, 16h plus 1 minus 1. Minus 16h plus 1 minus 1, minus 1. Which is the last ones. Middle two terms cancel. So the radical and the square cancel out, so we have 16h plus 1. Plus 1 over h, radical 16h plus 1 plus 1. So those cancel. The h's cancel. We have 16, radical 16h plus 1 plus 1. So we put 0 in there. Times 0 plus 1 plus 1. That's 0. Square root of 1 is 1. You gotta use the shortcut whenever you multiply conjugates. There's a shortcut. That's the difference of two squares. If you have two terms and they're conjugates of each other, that's simply the difference of two squares, because the middle terms cancel out. It goes both ways. I don't know. I can't help you till you finish the answer. Did you call it unfoil?
Oh my god. Factor, I'm sorry. I forgot. I know there's foil, but I was like, wait, there's another word.
Yeah, unfoil works just as, I knew what you meant.
Yeah, unfoil, but there's a word for it, but I forgot. I'm sorry.
Factor.
It just literally went out. Yeah, factor, yeah.
You have to be careful. Because the only way we can have a removal of discontinuity is if what? Yes. Did you plug in the 9 on both top and bottom and see if you got 0 over 0? Because that would be a cruel trick of creating a factor equation that happens. If it doesn't become 0 over 0, then you may have an answer that's undefined. The limit goes to infinity. But yes, this one does factor. So what makes up x squared? Signs go in the middle. What? Look at the second sign. Since it's a minus, they have to be opposite signs. One's plus, one's minus. The bigger one is minus, the bigger factor. What times what is 18? When you subtract them, you get 7.
2 and 9.
And the bigger number gets the minus. So the limit as x approaches 9 of x plus 2 is 11. It's 2. It's 11. What do y'all think so far? So far, so good? Okay, so write down these conditions first. Limit of f of x as x approaches b is 14. The limit as x approaches b of g of x equals negative 5. And I know you guys can see the answers already, but get used to writing them out the entire way. For example, how would I do the first one?
Add each.
Well, I would first take the f of x function, of the g of x. Limit of f of x as x approaches b is what? 14. Limit as x approaches b of g of x is negative 5. 14 minus 5 is 9. It's a constant. We can take the constant out in front. Again, use the properties of logarithms. I mean, logarithms, but limits. So his limit of g of x as x approaches b is negative 5. Positive times negative is negative. 8 times 5 is 40. The product property tells us what? X approaches b of f of x times the limit as x approaches b of g of x. Limit of f of x is 14 times the limit of g of x, which is negative 5. Positive negative is negative. So here's negative 7. Here is the quotient rule. X is 14. Limit of g of x is -5. Answer is negative. How many times does 5 go into 14?
2,
How many left over?
8.
So the answer is -2 and 4/5. Yes, 0.8, yes. So even though it's a lot of writing, get used to writing those because those are reinforcing the properties of limits. Pretty straightforward. Yeah, you need to back up there? Which one? Are you on C or D? All right. And the next one. Okay. Use the graph below to find the delta greater than 0 such that for all x's, 0 is less than absolute value of x minus c is less than delta, implies absolute value of f of x minus L is less than epsilon. So we're going to find the delta. So here's all the information you need. Yes. Where's our delta situated? X values. The epsilons are on the y-axis. So what we're looking at here is at 1, you take the shortest distance from, what's the rational equivalent to 1? What's the fraction equivalent to 1 in this example? 9 over 9. So from 9 over 9 to 4 over 9 is how far? 5. 9 over 9 to 16 over 9 is how far? 7. You're right. So we want the least amount. So we're saying that our delta is 5 over 9. Because that's going to incorporate, because it incorporates this small range, we know it automatically incorporates the upper bound, which corresponds to the epsilons being also true. Now, do you want to take a try at it algebraically if I didn't give you the graph? Or solve it epsilon delta proof. Inside the first one goes what? What's f of x? And the limit is 1. We're going to use this in a little bit. Yeah, since we're solving for delta, we have to define the epsilon. C is 1. So what's our goal? What do we have to do? We have to first isolate x, but we have to eventually get it to look like this, so we can compare the epsilon delta that way. If we drop the absolute values, what happens? We take the positive and negative of our solution. Then what? Add 1. 1 is actually 3 over 3. Three minus 1 is 2 over 3. 4 over 3. Now what? Yep, just get rid of the radical. So you square each of the terms. Remember, our objective is we have to try to get it to look like this. So what do we have to do? Subtract 1. And 1 is the same thing as 9 over 9. Four minus 9 is Negative 5 over 9. 16 minus 9 is 7 over 9. Are we done? No, because this one has the absolute values on it. So this is where we get our values from. The smaller of the two. We're setting epsilon equal to delta. Epsilon is 5 over 9. That's where we got that. So if I didn't give you the graph, if the question didn't give you the graph, you really wouldn't need that. You could do it with epsilon delta. There's the 14 and the 16 over 9. Then we subtracted 1. Use the graph to find the delta greater than 0. Interesting. Okay. And you use the method you used last time, just looking at the graph. Off the bat, you'd think, no. Is there another way we can do that then, without worrying about getting a common denominator? But just find the decimals of them. We could find the decimals of them and see which one's closest to -1, and that's going to be our delta. Or we could, I wouldn't want to, because look at the function. Where's the x on the function? It's on the bottom. So in order to solve for it, we would have to reciprocate it, which means flipping the signs, flipping the inequalities. There's a lot more work than is worth it. In this example here, it's much easier if we just use the graph itself and find the decimals. So -36 divided by 25 is what? 1.44? And then 36 divided by 49? So the question is, which one's closer to -1? Yeah, because the 36 over 25 is 0.44 away from -1. And the 0.73 is 0.27 away. Which was closer? -36 over 49. So our delta is 0.27. Yeah, so sometimes it's easier to look at the graph. But you were right. Looking at them originally, they didn't have common denominators, so we couldn't just use the graph straight up. Next thing we do is convert them to the decimals, and then see how far they are from the -1, and those are our deltas. So we're given the function f of x and the values of c and epsilon and limit L. Is the function there as x approaches c. Determine the largest value for delta greater than 0 such that our epsilon delta proof exists. So we first have to find our limit. What is our limit going to be? If we just plug in our values, what do we get? Get 0 over 0. Which means we got to factor it out. Is the numerator a perfect difference of two squares? Yes. It is made up of x plus 14, x minus 14. So the x minus 14s disappear. The limit as x approaches 14 of x plus 14 is 28. So that's our limit value. What do we do with this now? Epsilon delta proof. Because we're looking for what? We're looking for the largest value for delta using the epsilon delta proof. F of x less than some epsilon x minus c is less than delta. Start plugging things in there. Our function is x squared minus 196 over x minus 14 minus 28. X minus 14 what we have to do here first it's this one. We know this one comes out to be x plus 4 the rest of the delta side. I'm sorry. Because the top is the difference of two squares, we can factor them out and cancel the x minus 14s. We're left with x plus 14. 14 minus 28 is negative 14. Did the equation give us an epsilon value already? 0.009, yes. So what's our largest delta value? It is 0.09, But if we look at the x-axis, start off at, because our value point is 14. That's our C point. So the upper bound of that one is 14.09. We know that because of this right here, epsilon equals delta. And so delta equals, yes, it equals 0.09. So on our xy, it would be 14.09, and this is 13.01. The largest delta value you can use is 0.09, and the largest value it's going to give you is 14.09. All depends on what the question is going to ask for. The following function and its graph to answer parts A through D. Can y'all see it from back? Or me zoom in? This is a piecewise defined function. Here's the graph of it. So using that graph, find the limit as x approaches 4 from the right. So what's the limit as x approaches 4 from the right? 2. As we get closer to this value, it's approaching 2. As x approaches 4 from the left, where does it go? It approaches 2 also. Because as it comes over here, the y values all getting closer to 2. F of 4. Select at f of 4, what's the answer? Yeah, at f of 4, the answer is 1, 2, 3. Does the limit exist? Why? Right, because it approaches. It doesn't have to exist at the point or be the same. It just has to approach. Both sides have to approach the same value. Everybody okay with that? Same thing here. Graph the piecewise defined function, that one. Find the limit as x approaches -3 from the left and from the right. Does the limit exist? If so, what is it? Okay, let's first graph it. What do we know the graph is going to look like? Simply by looking at the equation. The first thing you have to do is look at the graph. Can you tell me about the graph? We know that at when these are my x values, these are my x values, these are my f of x values. So when x equals 3, what's y equal? When x equals 6. So as it says, when x equals 3, y equals 6. What do you know about this graph? What's it going to look like? What's the basic shape of it? No, it's a parabola downwards, yes. It's a parabola because it's x squared. It's going down, and the vertex is where? Where? Right. So all this graph does is it goes up 9 places. So when x is 1, we have 8. When x is 2, we have 5. Same with, because it's symmetric, what are the intercepts? Yeah, 3, negative 3. Take this equation, set it equal to 0, and square root both sides. So plus or minus 3 equals x. Those are my zeros. And so that's the graph. Is it continuous? The function itself is continuous. It's just that this graph isn't. So as we approach negative, that's supposed to be negative 3. Yes, negative 3. I'm sorry, I miswrote it. It's at 6. So as x approaches negative 3 from the left, what value is it approaching? As x approaches negative 3 to the left, what's the y value at that point? As x approaches negative 3 from the right, where is it approaching? Does the limit exist? Yes, because both directions equal the same limit point, and that limit is 0. Even though it doesn't exist at that point, it's at negative 3 at 6, is the limit it approaches it. You all like these. First step is what? Always plug in 0. Plug in the limit, the C point first. If you do that, what do you get? 0 over 0. So we know we're in good shape. So we do what? It is 0 over 0, yes. So our next step to fix this thing is what? Conjugate. Whenever you have radicals and it's 0 over 0, the safest bet is conjugates. So what's the conjugate of this function? Plus square root of 3, right. So it's radical h squared plus 10h plus 3 plus radical 3. What was the shortcut? We know the bottom is going to be h. Radical h squared plus 10h plus 3 do not have to FOIL. Shortcut? The difference of two squares? Yeah, so take the first term and square it. Gives us h squared plus 10h plus 3. Minus, take the second term and square it. It gives us 3. Threes cancel. On the top it's h squared plus 10h. And the bottom it's h times radical h plus 10h plus 3 plus radical 3. Next step. Factor out the h in the numerator and cancel it to the denominator, because we have to get rid of the 0 factor, which is the h. We have h plus 10 the h's cancel. So we have limit as h approaches 0, h plus 10, radical h squared plus 10h plus 3, plus radical 3, now can we plug in 0? Yep. All the h's go to 0. We have 10 over 2 radical 3. This radical 3 plus radical 3 equals 2 radical 3. Are we done? No. Mentions of algebra says you cannot have a radical on the bottom. How do you get rid of the radical on the bottom? Yeah, multiply top and bottom by that radical. Radical 3 is 3. Well, the 2 and the 10 cancel too. So the answer is 5 radical 3 over 3. Trigonometric functions. Yay! Or 17. The limit as theta approaches 0 of 2 sine radical 3 theta over radical 3 theta. So what's the answer to this one? Let's see how it got to. This is a constant coefficient, so it can go outside the limit. And radical 3 theta over radical 3 theta. Because we have this already proven many times, the sine of whatever, as long as these are the same, it'll equal 1 as theta goes to 0. So radical 3 theta, radical 3. So this whole equation here goes to 1. 2 times 1 equals 2. That's it. So far, so good? Is anybody still kind of lost or confused? Or getting better?
Getting better.
Question number 18. The limit as y approaches 0 of sine 11y over 15y. So what do you think we have to do first? As y approaches 0, 1 over 15 times sine 11y over y. I can do that. Yes. Just move this in out front. It's a constant, so where does it go? In front of the limit. I need down here to use this rule. It has to be 11 down here. Can't I just put 11 down there? I got to multiply 11 over 11. So this 11 can multiply to this. times 11. This whole thing times 11. It's a constant, so it goes out in front. 11 over 15. Limit as y goes to 0. Sine 11y over 11y. What happens to this limit function? Goes to 1. So our answer is 11 over 15. Yeah, this is super heavy algebra. I mean, it's not much to it. It's calculus, we haven't really gotten into calculus yet. Because we still haven't gotten to the definition of a derivative. We've touched on it, but we haven't actually touched upon, done anything with it. As x approaches 0 of tangent 4x over x. Remember, what's the rule that we're looking to try to get this thing into? Screens. We need to get theta goes to 0. We need to get sine theta over theta, where theta could be anything. It could be 7x, it could be 15y, but they have to be the same. How do we do that? Yes, that would be the first step. Then what? Well, we have a compound fraction here. Let's fix that first. So take the top fraction, leave it alone. Multiply by the reciprocal of the bottom fraction. That's just what we needed because we can now combine the sine 4x over x times 1 over cosine of 4x. Everybody good so far? So what are we missing in front of the x here? 4. It needs to be a 4x. So I multiply 4 over 4. This 4 will go with that. This other 4 is a constant, so it goes out in front. So I can split them up now. I have sine 4x over 4x times the limit of 1 over cosine 4x. What do they become? This one becomes what? 1. This one becomes what? Next goes to 0. Cosine of 0 is 1. So it's 1 over 1. That becomes 1. So the answer is 4. What are we supposed to get out?
220.
Oh, crikey. That's why you were getting ready to go.
I was like, it's 20. That's tough.
Okay, the rest of these, I'll put together a video and send them out to y'all. All right, thanks everybody. Do your homework.